Hello and welcome to Interpreting P-Values. So this is part of section 9.1 as well. Please watch this video after you watch the null and alternative hypothesis video. This video will make a lot more sense after you watch that one. So interpreting a p-value. We're going to talk about what is a p-value, what does it mean, how do we interpret it, and how do we use it in a problem. If we think back to the first video about significance tests, we said that in a significance test, we're looking for evidence against a claim. So we're looking to say, getting this outcome is very, very unlikely. So the whole goal to prove the null hypothesis wrong, or to say that we think something is up, we think there's a difference in the claim and the parameter, is to look for evidence against the claim. So like I said, we have two types of hypotheses, the null, which remember is always the equals hypotheses, and the alternative, which is going to be the greater than, less than, or not equal to hypotheses. So we talked about last video, this is part of our state step. And in significance tests, we do the state, plan, do, conclude, same four-part sequence that we did for confidence intervals. So this is how we set it up. This is what we talked about last time, but what is the goal of a significance test? Well, in a significance test, we're looking for how likely is this outcome to occur. Is it likely or unlikely? And we talked about we have three different types of tests, and we have a positive one-tailed test, a negative one-tailed test where we shade below, and then a two-tailed test where we shade both sides. What do these distributions look like? What do all these little curves look like? They look like a normal curve, and they look like a z-score problem. And if you think back to z-scores, we did this same thing where we marked our z-score or we marked some value, and then we either shaded above, below, or on both sides. And we said this area right here, this tiny area, we called the probability. Well, all a significance test is we want to find the probability of getting a statistic or a sample assuming the null hypothesis is true. So the probability, or the area under the curve that we've been finding for so long, is the same as the p-value. They're the same number, it's the same process and the same idea. We're just finding different kind of markers on our curve to tell us where to look for that p-value. So to answer the question, what is the goal? The goal of a significance test is to find the probability of getting the statistic or of getting the sample data, assuming the null hypothesis is true. So we're saying if the claim is true, if the mean truly equals the claim, or the proportion truly equals the claim, what's the likelihood of getting my sample? And if you think about z-scores, the smaller the p-value, the more unlikely, the bigger the p-value, or the bigger the probability, the more likely. So all the p-value is the probability or the area under the curve, and finding this value is the whole goal of a significance test. So key point one, the p-value is the probability of observing a statistic or sample data as extreme or more extreme than the one we observed. And the p-value comes from using your statistic to mark on your curve, and the p-value is the probability, is the area under the curve. So how do we make conclusions with the p-value? What does the p-value kind of tell us? Well, we have two outcomes that could happen. The first is if the p-value is small. So small is usually less than 5%. So we could write that is if p is less than 0.05, we reject the null hypothesis. So if the p-value is small, that means the probability is really small, or the probability of getting our sample is very unlikely if the null hypothesis is true. So we can reject the null hypothesis and say, I reject the idea that the true mean equals the claim, or I can reject the idea that the true proportion equals the claim. So in other words, we have convincing evidence that that the true parameter, we have convincing evidence that the true parameter is not equal to the claim. So we have reason to believe that the true parameter is different than the claim. That's if the p-value is small. And small, we said is going to be about 5%. I alluded to that before in other examples, but this is like where we kind of bring this up in real time. Being unlikely usually means less than 5%. So if the p-value is large, or if p is greater than 0.05, and it's usually 0.05. It will change from problem to problem, but usually 0.05. If p is bigger than that, or if there's more than a 5% chance of this happening, that means we fail to reject the null hypothesis, meaning we can't reject it. We cannot say that there's a difference. We can't say that it's true. We can just say we failed to reject the claim that they're the same. So this wording is going to get really tricky and annoying, and there's going to be some double negatives. So if you're like, why are you saying fail to reject? It's just because we have to use this terminology. We cannot say accept. So if the p-value is large, we do not have evidence that there's a difference between the true parameter and the claim. So I cannot reject the null. So if we think about small p-values, and we think about the normal curve, think about if something was way up here and there was a tiny little area up here, or way down here in a tiny little area, that would be a small p-value. It's a very unlikely outcome. So I could reject the null hypothesis. A large p-value would be something like if I had a z-score up here and I shaded way up here, well, there's a decent amount of shaded area, meaning it could happen. So it's a large p-value, which means I failed to reject the null. Same thing on the lower side. If I had like a z-score right here, and I had all that area shaded, that's a pretty decent sized area. It's not too rare to be in these blue regions. So I failed to reject the null, meaning I do not have evidence that they're different. So we can never accept anything. No matter what we're doing in our test, we either reject or fail to reject. I can never say that I accept the null hypothesis or that I accept the alternative. I can never accept anything. I just reject or fail to reject. Those are the only two options. So how small is small? So we said usually 0.05 or 5% is the cutoff, but in order for something to be statistically significant, and you'll see this phrase a lot, like, is it statistically significant? The p-value must be smaller than alpha, or our significance level. So alpha is my significance level, and it's just that kind of Greek look alpha right there. So it's kind of like a little, like a fish, if you've seen like little fishes like that. So if p is less than alpha, I can reject the null hypothesis. So what is alpha? Alpha is this little symbol. It's the measure of how certain we want to be, or the percent of time we're okay being wrong. So usually alpha is going to be like 0.05, meaning we could be wrong 5% of the time and be okay with that. But if you think about, an alpha level, depending on what it is, there are some things I don't want to be wrong 5% of the time. I only want to be wrong 0.001 or about 0.1% of the time. So depending on your scenario, alpha is going to be different, which is why if p is less than alpha, I reject the null hypothesis, or if p is small. If p is large or bigger than alpha, I I fail to reject it. Also, alpha is going to be given to you in every problem. So you're not going to have to create it. It's going to be stated in the problem. So key point number 2, if P is less than alpha, we reject the null hypothesis. If P is greater than alpha, we fail to reject the null hypothesis. So here's a quick example. It says the mean weight of loaves of bread produced at the bakery where you work is supposed to be 1 pound. If you watched the previous video, this is a similar example. You are the supervisor of quality control at the bakery, and you are concerned that the new personnel are producing loaves that have a mean weight of more than 1 pound. You decide to investigate and weigh a random sample of bread loaves and find the mean weight to be, mean weight is 1.025. You conduct a significance test, which yields a p-value of 0.086. So we're given a p-value this time. In the first video we weren't, but we're going to start off the exact same way. What are the null and alternative hypotheses? And then state the population and parameter. Well, we said the population was all bread loaves. And the parameter is we want to find the true mean weight, or we want to estimate the true mean weight. So we want to test the true mean weight mu. The hypotheses, the null hypothesis, is that the true mean equals 1 pound, because it says they want the bread to weigh 1 pound. So mu equals 1. The alternative, we think they're making bread that weighs more than 1 pound, so we think mu is greater than 1. So it says, what conclusion would you draw at the alpha equals 0.5 level? Well, if alpha equals 0.15, and I think about my p-value and alpha, a p-value of 0.086 is greater than 0.05. Well, if the p-value is greater than alpha, then we fail to reject the claim that mu equals 1, or the bread weighs 1 pound. So if I write my conclusion in context of the problem, that's going to be super important. I will say we fail to reject the claim that mu equals 1, or the bread weighs 1 pound. So, fail to reject if p is greater than alpha. I'll do a little greater than sign there. Part C says at the alpha equals 10, alpha equals 0.1 or 10% level. Well, if p is 0.086, that's less than 0.10, or p is less than alpha. So at the 10% level, or at the alpha equals 0.1, we reject the null hypothesis. So we reject the null hypothesis that mu equals 1 pound. So you can see I worded my conclusions a little bit different. You can choose the one that works for you. If you want to say we reject the null hypothesis that the mean equals 1 pound, or we fail to reject the claim that the mean equals 1 pound, which means the bread weighs 1 pound, you can kind of choose and play with it. The 3 pieces that your conclusion should have is they should incorporate the p-value, they should say reject or fail to reject, and they should have context. So that's a wrap. We use p-values to draw conclusions about a claim. If the p-value is small, we reject the null hypothesis. If the p-value is large, we fail to reject. And we never state the alternative in our conclusions. That's a wrap, and I'll see you next time.